Good morning or good afternoon, everybody, and welcome to this event organized by Milestone. I'm Serena Lorenzi. I'm Communication Manager at Milestone, and I'll be your moderator for today's webinar. Today's live event is titled Best Practices in Sample Preparation of Baby Food for Trace Metal Determination. What are we going to see during this webinar? In this webinar, we will explore how to successfully implement a method to meet the FDA Closer to Zero plan and the total sample preparation approach combined with ICP-MS will be evaluated to consider the control of all sources of contamination and the best practices to control them. So with that in mind, here is how to get the most out of your webinar today. So this event will be recorded, and the recording of the webinar will be sent out to all of you by tomorrow. It is worth it to mention, please feel free to share any questions whenever they come to mind using the Q&A box also during the presentation. And also any thought or comment is welcome. We will follow up to some of your questions at the end of the presentation today. And for any unanswered questions, we will reply by email in the next 24 hours. Any technical issue can usually be solved by leaving the event and entering again. But if not, please contact us in the chat box, and the backend team will get you back up and running as soon as possible. If you enjoy what you see or listen to, please consider share the recording with your colleagues or by posting this event recording on your LinkedIn or social media profile. All right, everything is set to introduce today's speaker. Gianpaolo Rota has been an application chemist at Milestone for over 15 years. And thanks to continuous collaboration with laboratories and universities located all over the world, he gains substantial expertise in sample preparation for elemental analysis with a focus on microwave-based instrumentation. In the course of his work, Gianpaolo develops new application methods, participates into international conferences, organizes training courses, and provides ready support to analytical laboratories. So everything is set. This presentation today will last about 40 minutes plus the question and answer session. So thank you for your attention. And now, Gianpaolo, you have the floor. Thank you. Gianpaolo, you have the floor.
Welcome everyone in this new Milestone webinar. My name is Gianpaolo, and today we focus our attention on baby food samples. In this presentation, we will see all the steps related to the sample preparation in order to improve the trace metal determination of the samples. Before to speak about baby food, let's have a look to have an overview about the control of heavy metals in food. Because today there are some limitations that regulates the concentration of some metals, especially arsenic, cadmium, mercury, and lead, that are recognized as the most toxic elements inside the food materials. For food materials, I mean all type of food, including also baby food. Of course, it is recognized that these type of elements are very toxic for everyone, but especially for babies and children who are most vulnerable to the neurotoxic effect of these elements. For that reason, the FDA promoted a new initiative that is named as a Baby Food Safety Act that starts in 2021. Basically, the target of this new initiative is to reduce, or anyway to eliminate this element, the presence of these four elements in baby food materials, baby food products. This it's an initiative with the intent to reduce as much as possible the exposure of children to these, of course, to these four elements. So these, the Baby Food Safety Act puts some very low limits, and this, of course, generates some new challenges for producers of baby food materials. So the producers must increase the monitoring of the ingredients and the finished products, and they have to apply new strategy in the manufacturing if they are out of such limits. This, of course, put even some new challenges for food laboratories, because these new regulations reduce the level of the maximum level of these elements inside the baby food materials. And of course, laboratories need to be equipped with the proper instrumentations and the proper methods in order to obtain solid data, robust results, even working at a very low level of quantification. And just to give you an idea, the actual method that is recommended by FDA is the EAM 4.7, and the LOQ that are presented in that methods are listed here. So we are talking about 11.6 ppb for arsenic, 3.7 for cadmium, 10.9 for lead, and 7.8 for mercury. And if we compare this LOQ with the limits that the Baby Food Safety Act puts, as you can see, we are higher, or anyway very close to the limitation. So this LOQ is, the LOQs for arsenic is higher of the limit, of the maximum limit of arsenic that can be present into the final product, into the baby food product. The cadmium, it's very close to the new value, to the new limitations. Lead is much higher, and also mercury is much higher. So this means that, of course, needs to be the method for determinations of such elements needs to be improved. Method and also the equipment adopted in laboratories in order to reduce the LOQ and have better results and robust results. How to improve the conditions, the LOQs of your labs? Of course, we have to consider to adopt a proper analytical equipment and a proper sample preparation workflow. Concerning the analytical equipment, the ICP-MS is the system, is the unit that allows to reach a very low detection limit and then plays an important role in to reduce the limit of quantifications. So ICP-MS make possible to really reduce the level of external contaminations and then to allow to work really close to zero. But the analytical equipment is not enough. We have, of course, to consider also the sample preparations. And when you work with an ICP-MS and when you are working at such low level, of course, we have to consider some important things, and we consider some challenges that this takes into laboratories. The first, of course, is related to the external contaminations. External contamination that could come from the acid used for sample prep and for preparation of the standard, from the air of the lab, from the vials used to storage the sample, and many other factors. The other things is related to the sample complexity and the matrix effect that the samples can bring into during the analysis. So it is very important that sample preparation is efficient, and that we adopt a method that, in any case, for all baby food materials, basically I obtain a good digestion of sample ready to be analyzed with ICP systems. And this, of course, impact also on the LOQs. And all these things must be considered without losing the productivity, because as we have seen before, of course, the number of analyses increase, and anyway, food labs always, from my experience visiting laboratories, I see that the productivity is an important thing that must be considered. So basically, the challenge can be summarized in increasing the quality, but without losing productivity, or anyway, increasing also the productivity if it is possible. To do this, one thing that we have to consider is, of course, the sample preparation workflow. I'm talking about the workflow because the sample prep is not only the digestion of your sample. Digestion is one step of the total workflow. But later I give you more indications about that, more details about it. What is important here is that a good optimization of the sample preparation process have a high impact on the final results that you obtain with your ICP-MS system. So especially talking about ICP-MS, you have to consider a proper sample preparation method in order to minimize possible contaminations and have a high efficiency and have a good digestion of all your samples. The sample preparation workflow has an impact on several aspects. And the first, of course, is related to the speed. And this, of course, increases the productivity. Increase or anyway maintain the productivity at very high level. So an automated workflow, for example, helps you to speed up the sample preparation process. The other aspect is related to the quality. Quality, I mean the possibility to avoid external contaminations, to remove impossible interferences, and to have a good reproducibility of your data. Then the efficiency, so it means to reduce basically the cost per sample, and then minimize the disruptions that can happen during the sample preparation. So minimize all mistakes that can run during the sample prep, and that obliges you to repeat all the process from the beginning, and then these basically double all the time for the sample preparations. So all these aspects can be improved by applying a proper sample prep workflow. What does it mean, sample prep workflow? The workflow starts from the weighing till the digestion of your sample. So the weighing is an important process, and considering baby food, the typical sample mass is 0.5 grams. The FDA EAM 4.7 recommend 5 grams for liquid samples, but if we consider the dry matter, it's half a gram. And half gram provides a good homogeneity of the sample. In some cases, it is also possible, in some cases recommended, to increase the sample amount. This increasing the sample amount, of course, you have an increase of the concentrations of final solutions, especially considering if you are working at a low level of detection. But later I give you more details about this aspect. What is really important here to point to see is that when you work with such such mass of sample, it is important to consider to have the right and proper unit, especially for digestion, to handle this material. The weighing is an important aspect of the sample preparation, and especially considering the weighing part of powder materials and baby food, for example, like milk powder, it's one of them. It is important that the weighing process is precise. And then when we talk about microwave systems, when you work with plastic container like the Teflon tubes used for the digestion with the microwave systems, it is common that the scale is not very stable due to the electrostatic fields. For that reason, Milestone provides ionic hair fan systems that remove electrostatic fields and then improve the stability of the weight. It's a very simple tool that helps you to have stability of the balance. So the stability is reached in a few seconds, and then you can have the exact weight of your samples. And then, of course, you don't have the problem that when you are weighing the powder it's attracted by the external part of the vessel. That is not so complicated, but I understand that it could be an annoying part of the weighing especially for when you weigh the sample into the digestion. So this is the first part of the workflow. The other things that we have to consider is the reagents used. Most of the external contaminations come from the acids that you use for the sample preparation. So it is important to have the right acids according to the analyzer that you are using and to the detection level that you have to reach. So the acids normally used for the digestion of baby food are nitric acid, some cases even some peroxide. Usually it's a mixture of nitric and 1-2 ml of peroxide. Peroxide helps to digest samples with high fat content, and it is also recommended by the FDA EAM 4.7, so the regulations for the food, to add some hydrochloric acid that can be used before or after the digestion process in order to stabilize some elements, in that case to stabilize mercury. So these are the most reagents used, especially nitric acid. But what is important to consider is the quality of the acid that you have in your lab. There are different types of acid purity, from the high purity ones to the acids with the lowest purity. Of course, considering that we are running the sample preparations for an ICP-MS system, it is recommended to work with a high purity acid. The high purity acids minimize the interferences, minimize the external contaminations, and then provides high quality of the final data. Of course, high purity acids are more expensive than acids with a lower purity. And this increases the total cost of the analysis. However, there is a technology that allows us to produce high purity acid directly in your lab. This technology is a soup boiling distillation system, and it is a boiler like the one that you see in that picture, where we load the acid here, let's say the low quality acid, and then by a gentle heating of the surface of the acid, the system produces some vapors of high purity acid that are recondensed in a second flask. So in this flask, you collect the high purity acid. This has a high impact on of course, on the quality of the data, because the acids that you collect here, it's very, very clean, and it's comparable with the acids that normally you can find on the market and that you can buy from big brands of producers of acids, of reagents. But the second thing that is important to consider is the impact on the cost. So basically here you are loading, you buy a low acid quality, and of course the cost of this acid is much less than the high quality ones, and this helps laboratories to save, basically reduce the cost per analysis, up to 90% cost saving of ultra pure acid, as you can see in this slide. And I mean, I also add another aspect that is very interesting, that you can produce the amount of acids that you need for the day. And these basically have a high impact on the contaminations, because when you buy a bottle of high purity acids, every time you open and close the bottle, you are adding contaminants to this bottle. With a system like that, you just produce the amount of volume of acids that normally you use for the day, and that's all. So this is has also a very high impact on the LOQs at the end. And just to give you an idea, this is are the values, some values obtained by an acid with these are taken from the certificate, and these are the values obtained after the blanks obtained after the cleaning, the purifications by using the subboiling distillation system. Milestone has two units like that. One is named Duopur and the other one is named Subclean. The use of one or the other depends about your needs and about the acids that normally you have to purify in your lab. The other aspects, again related to the reagents, is the handling of the reagents, because the purity of these reagents is important, but also the handling of it. So when you add it to the vessel for the digestion, for the sample preparation, there is the risk of some human error and risk of contamination. Imagine that you are working under a fume hood for the injection of the acids, and the fume hood is not in the proper conditions. This, of course, have an impact on the blanks of your analysis. And then, of course, there are risks of human errors. What does it mean? It means that if you have hundreds of samples per day, and it is normal, I mean, or can happen at least, that when you constantly load acids into the vessel, you jump one position, and then one position is without acid. What does happen here? Happens that the sample is, of course, not digested, the sample burned, and then you have to repeat the test again. So you have to rerun another digestion process. So the best way to avoid any human mistakes and also to minimize possible external contamination is to have an automated system that automatically introduces the acid inside all vessels. Of course, this is a robot, let's say, so it's an automated system and it cannot make mistakes. And of course, it's a closed, small and closed system that is constantly ventilated and reduce any possible contaminations that comes from the external environment. Milestone provides a unit like that is called EasyFill, that you see here in that picture, and that, of course, impact a lot on the LOQs, because these strongly reduce operator the mistakes and then make some difference from the manual injections and the introduction of reagents by these units. As you can see, the data are more or less similar using automatic pipette injections and the system, the automated system, the EasyFill system. Consider that, of course, it's an automated unit. So the other advantages that you can have is that while the unit works, you can spend this time doing other things in your lab. So it's a extra time that you have in your lab to use for other things. There are some improvements for some elements, of course, but it depends even about the condition of your laboratory and the type of reagent that you are using. Of course, the other steps of the workflow that really impact on the LOQs are the digestion system that you use in your lab. Baby food, it's a food, let's say it's compounded by a big variety of material, big variety of ingredients. So baby food is a complex matrix made by various components: proteins, fats, carbohydrates, and vitamins. And these, of course, it's important that your digestion system is able to fully digest all type of baby food and all type of matrices. Because an incomplete digestion can make problems, especially for an ICP-MS, especially working at a low detection level. So this an incomplete digestion makes some interferences during the analysis, and the matrix effect that you have on the final solutions can lead to the signal suppression or enhancement. So you have a false data here. The digestion conditions normally recommended for food is 180 degrees. Normally, 180 degrees is the minimum temperature. If you can digest your samples at higher temperature, it's even better. Because higher is the temperature, then the quality of the solutions that you obtain is higher. That means you have the fully digestion of all possible matrices, all matrices of these of food materials. And the food materials can interact in different ways. There are samples that are with higher activity, for example, like milk powder, and samples with lower activity, for example, vegetable materials, or samples with high water content. However, the digestion system must be able to handle both situations. And it is important that you have a proper unit and also a proper method in order to fully and completely digest all type of matrices without any matrix effect on your ICP system. Nowadays, the technology commonly used in laboratory is a microwave systems. There are two different microwave units that you can use in your lab. The rotor-based unit, like this one, or the single reaction chamber system. Both are microwave systems, but with different performances and different technologies. And considering the rotor-based technology, we are talking about a microwave oven with the rotors, that works with rotors, that are closed and sealed vials, closed and sealed vessels, sorry. And we perform the digestions monitoring the temperature. In the Milestone system works, the lithosuction unit that you see here works with an easy temp sensor, that is an infrared sensor that is transparent to Teflon and reads the internal temperature of all the positions. This, it's extremely important to have a good reading of the temperature and to have a good control of the pressure. So the vessels that you are using and the vessel and the rotor configurations that you are using, this technology must be in compliance with the type of the sample that you are digesting, especially concerning the pressure that these samples can generate. The selected rotor for baby food that Milestone provides is the Maxi 24 HP. It's a rotor with 24 positions, works with high purity Teflon vessel. And basically, you load half gram of samples. I always refer to dry matter, so half gram of samples. Then 8 ml of nitric acid, 1 ml of peroxide, that are the recommended volume of the FDA EAM 4.7. And the digestion temperature that you can reach using that unit is 210 degrees. At this temperature, it is possible to fully digest all type of food materials, all type of food ingredients. The final dilution after digestion is 100 ml, considering the acidity, of course, when you work with 8 ml of nitric acid. And working with this type of digestion system and applying the FDA 4.7 EAM method, as you can see, we can really reduce the LOQs comparing the ones declared in the method. And we are really in compliance with the FDA initiative, the Baby Food Safety Act. I mean, as you can see from this data, here there are listed the LOQs from the EAM 4.7 method. These are the new legal limits that the Baby Food Safety Act want to introduce. And then here the LOQs that we recalculated using our workflow from the weighing and the purification of acids, the automatic injection of reagents, and the ETOSAP system with the Maxi 24 HP rotor. As you can see, we are really close to the zero here. The other things that I want to point out is related to the pressure. So when I say it's important to find the right configurations, I say it's important to find the right rotor according to the samples that you have to digest. Baby food require to use a rotor that allows you to have a good productivity, but also that it's able to handle even high pressure. Our vessels are all designed in order to control the internal pressure of in all the positions. So there is a safety springs on the covers, and if you have a high pressure inside during the run, the covers open and release the excess of fumes and then close again. So the system has an automated way to control the pressure in all the positions. And even if you have the release of the pressure, you have anyway the full recovery of all elements. For example, mercury, that is recognized as the most volatile one, because the opening and close, it's very, very fast. Together with that rotor, we also provide an automated system to close the vessel. Is the name of the unit is EasyCap, and basically it's a system that automatically helps you to fastly close the vessels of the Maxi 24 HP rotor. Considering the single reaction chamber technology, we have a completely different unit, still a microwave unit, but instead to have an oven, it has a reactor, stainless steel reactor that is able to reach very high temperature and pressure conditions, much higher than any other rotor-based unit. These units allow you to work with less amount of acids and higher sample amount, and this, we will see later, have an impact on the LOQs. And of course, the unit, especially due to the easy handling, allow you to have a higher productivity compared to any rotor-based system. The system works with racks and bias, so we do not have rotors here. So even the weighing is much faster. You have not to close the bias, but you just put a cap on the bias, and then when the rack is introduced inside the reactor, as you can see in that video, and then the reactor is closed and sealed by these clamps that you see. After the sealing, the unit close the front panel, of course, and then introduce nitrogen gas, and the nitrogen gas increase the internal pressure. This pressure close all the vials. Basically, this pressure increase the boiling point of the reagents, and these avoid any cross-contaminations from one position and the other. After that, there is the generation of microwave by the magnetron, and then, of course, everything is monitored by an infrared sensor, as we have seen here, that we also use in that unit. The programs run, with that unit you can reach extremely high temperature conditions, and then when the digestion is complete, there is the cooling of the reactor. In that case, it's made by water, and it's very fast, and then the release of the pressure, and you can then remove the vials for dilution and analysis. All these steps are most of all the steps that you see in that video are automated by the system, and these speed up the process for the sample preparation and increase the productivity compared a rotor-based system, just because the handling is very, very fast, very, very easy. As I said, the vials are easy to close, and you can work with quartz vials, Teflon vials, and disposable glass. When you work with disposable glass, you don't need to have you don't need to run any cleaning methods after the digestion, because basically it's disposable. So you just put in the trash and take a new vial. And these further increase the productivity of your laboratory and decrease any possible external contaminations from the vials. For the cleaning methods later, I will give you more details. So, considering this technology, the baby food samples, we recommend a configuration of 20 positions for baby food samples. It's a rack with 20 vials, and in each vial it's possible to put different types of samples. And the digestion samples can be done even with a higher sample amount and less reagents, because the performance of that unit allows us to work in that conditions. So in that case, it's possible to perform digestion with 1 gram of samples with 5 ml of nitric acid. Of course, we are a little bit out from the official FDA methods. That anyway needs some improvements, of course. But this is an aspect just to give you just to give you an idea about the performance of the unit. The digestion was done at higher temperature, 250 degrees. And this temperature is not possible, it's not possible to reach this temperature with a rotor-based system. Only a single reaction chamber can reach that temperature. Of course, higher is the temperature, better is the quality of the solution, and less matrix effect or less carbon effect you have on your ICP analyzers. And since we use less volume of acid, the final dilution can be less. So instead of diluting to 100 ml, we dilute to 15 ml. Sorry, this is a mistake. It's 50 ml and not 100 ml. It's a typo. Okay, having said that, considering these methods, it's possible to further decrease the LOQs, because as you can see in this table, now the LOQs it's really, really close to the 0 level. So the LOQs are using this workflow, using the ultra wave system, the single reaction chamber system, it is possible to minimize the LOQs to 0.12 for arsenic, cadmium, lead, and 0.023 for mercury. It's very, very low, especially compared to the actual EAM 4.7 LOQs. The other aspects are related to the cleaning methods. Of course, to keep low lengths, to keep very low, very low LOQs, it is very important to adopt proper cleaning methods in order to avoid any cross-contaminations. One very common cleaning method is the acid leaching. So just placing the vessel, the vials, and the glassware in an acid bath overnight, under fume hood. And this brings some issues, especially considering that you are working with an ICP-MS and that you need to work close to 0, because this type of cleaning is not really effective if you want to work at trace metal level. And of course, this takes other disadvantages, like the exposure to the acids under the fume hood, that is of course not very nice, and then the acid consumption. Another way of cleaning is to use an acid steam cleaning device. So it's a design system. Milestone has the trace clean that works with this technology. Basically, it's a unit that generates acid vapors, and the acid vapors, by recondensation, cleans the vials, the glassware that is involved into the analytical process. And it's an automated system. The system is a unit designed to do this. I mean, so you, while you are cleaning some vessels, you can use another batch of vessels or vials to run continuous your digestion. So you have not to stop the run, I mean. And normally one cleaning takes between 1 hour, 1 hour and 30 minutes. Depends about the level of purity you have to reach. And just to give you an idea, these are the level of blanks obtained by cleaning the vials, the PTFE vials and the post vials of ultrawave, and the ethos up vessels, the maxi 24 HP vessels. As you can see, are much lower than the detection level that you have to reach. Of course, other things, as I said before, is the use of disposable glass vials that really helps to basically eliminate these steps. So it's one step less that you have to consider. So, as you have seen, the sample preparation is made by different steps, and Milestone provides different products, different technologies in order to cover all the sample prep workflow, the total workflow. And this has a high impact on the quality of the data that you obtain, especially if you work with an ICP-MS, especially if you have to work at such a low level of detection. If you need more details and about this workflow, and about if you want more data, if you want to go deeply into this discussion, I suggest you to download this ebook that you can find directly on our website. And inside here you can find all many informations related about these discussions that we have done now. So I thank you, all of you, for your attention, and now I'm ready to answer to some of your questions. Serena, please.
Yes, Gianpaolo, thank you for your presentation. And let's now open the question and answer session. So if you haven't asked any questions yet, feel free to do it now in the Q&A or in the chat box, and I will read some of your questions to Gianpaolo for you. Okay, let's start from the first one. Gianpaolo, which acid can be purified with the subboiling units?
With this unit, you can purify all acids that commonly are used in laboratory. And I mean nitric acid, of course, that is very used for digestion of food and maybe food materials. Then you can purify is also hydrochloric acid, that, as we have seen, it is also used, some labs use it to stabilize some elements, but there is also the possibility to purify hydrochloric acid. If you use these acids, that is not very, it's rarely used in laboratories, but some of you, I know, that use these reagents for, due to the presence of silicates in some materials. We provide two different units. One is the duopur, the other one is the subclean, and you use one or the other according to the type of acids that you need to purify and according to the productivity that you need in your lab.
Okay, thanks. And again, regarding cleaning, apart from vessels and vials, do I need to clean the caps in the ultrawave, and how?
The caps can be clean, of course, and you can use, as we have seen, the trace clean system, so the acid steam unit for the cleaning of the caps. So you can use this unit, or you can use your microwave system for that type of cleaning. very honestly, the cleaning of caps is something that it is useful, but I mean, the critical part of your vessel is the bottom of the vessel or the vials if you have an ultra wave, not really the cap, because the cap is not in contact with the sample, and then due even to different temperature gradient, there is a constant refluxing of acids during the digestion, and this means that the cap is not in contact with the elements that are present inside your samples. So it is not necessary to have such a frequent cleaning of caps. Of course, if you work at PPT level or very low level, yes, this could be something that you can do. And for the cleaning, you can use your microwave system, or you can use if you have a trace clean unit or an acid steam system.
Okay, thank you. And is it possible to use also a microwave unit to clean the digestion vessel, and how is effective?
Yes, and it is very effective. The cleaning using your microwave system is another way, or is another method that you can adopt in your lab for the cleaning of the digestion vessel. And if you have a Milestone system, into the library you have method for the cleaning of the digestion vessels or the digestion vials. However, it is very effective, as I said, but this is designed for the digestion vessel, while an acid steam system like the trace clean, it's a system that allows you to clean digestion vessels, vials, round bottom flask, some ICP parts, so you can even clean and decontaminate the glassware. And then consider that if you have a lot of samples per day, you have to stop the microwave system just for the cleaning of your vessel. So these could have an impact on the productivity of your laboratory. Having a system, a design, a dedicated system for the cleaning, you can have two batches of vessels, and while ones are running into the digestion system, you perform the cleaning of the other one, and then you switch. So, however, the cleaning by using a microwave system is in a way very effective, much better than the leaching method, to be honest. Okay.
Great, thank you for your explanation. And another question is, can I use hydrochloric acid in the ultrawave unit?
Absolutely, yes. The ultrawave is designed to work with all type of mineral acids, hydrochloric, HF, phosphoric, even perchloric in some very rare cases. Consider that the ultrawave, if we consider food samples, the amount of hydrochloric is very, very small, but this unit is also designed for the digestion of rocks materials and inorganic materials, where we normally use that unit. We use a huge volume of hydrochloric acid. So the system is designed to handle all type of acids, working at even the highest temperature that you can reach with this system, and without adding any extra parts to the system. So the system is ready to handle all type of reagents.
Great, thank you, Gianpaolo. And I think I'm going to ask you the last question for today, because we are running out of time. So can you give some advice on how to control the external contamination, environmental, you mean? Yeah. It's
a very good question, and probably I need to do another webinar to answer to this question, because the variables are really, really a lot. External contaminations, it's a word that includes the environment of the lab, and it means the air of the lab, the operator that can anyway influence the blank, the conditions of the fume hood, the conditions of the pipettes that you use. There are many, many different things. What I can recommend you is to have a look to our book. That is, the name of the book is Think Blank. It's a book that we released some years ago. And here inside you have a sort of guideline that give you some indications on how to reduce the blank of your lab, starting from the easiest things. So starting even from the contaminants that could come from the operators. It's an interesting reading that I recommend to you, that I recommend to all of you. So you can find, if you need a copy, you can contact us.
Yes, thank you, Gianpaolo. We have another question asking for the acid consumption per cleaning using the trace clean, but I don't know if you can just explain it now or.
Yeah, it is basically you do not have to replace the acid after each run. I mean, the unit works with 500 ml of acid and you use it. I mean, since the vapors are clean, you don't have to, after each run, to remove these acids and refill with other 500 ml nitric acid, the trace clean. Concerning the consumption, because of course part of this acid then it's lost during the run, consider that it is recommended to change these acids at least once per month. Once per month if you use the unit every day. So, I mean, it's a very long use, and the consumption of nitric acid per run is very, very small. Now I don't remember the exact values. I have to check on my computer, my data. Anyway, if you need more information, you can contact me, and then I can give you more precise data about it.
Great, thank you for helping me in answering to all these questions. So thank you also the audience today for watching and for participating in our webinar. You will receive an email message informing when the webinar will be available for replay tomorrow. We wish you all the best, and we hope to see you all to our next event. Thank you and goodbye.
Thank you, everyone, and see you in the next event. Bye-bye.